Hey guys, welcome to the last section of chapter 8. This is going to be basically taking all of our rules from radical functions and applying it to an equation where we have to solve. And I'm going to show you a couple different examples and a couple different methods, and there's no one method that's any better than another. You just use whatever's comfortable for you, okay? So we're going to just jump into some basic examples of solving radical equations. Just as a quick reminder, remember radical equations are when you've got a square root, when you've got a variable in there. If it just says, for example, the square root of 3 plus x equals 1, that is not a radical equation because the x is on its own. It doesn't have a square root, a cube root, a fourth root, nothing, okay? Because this right here is just a number. So it has to have the radical with a variable in order to be calling it a radical equation. Okay, so let's look at example 1. It says we've got the square root of 5x plus 1 minus 6 equals 0. So just like if you were solving a simple linear equation, you're going to want to get x by itself. So to do that, you have to make sure you move everything over to the other side and then start solving for x. So the very first thing I'm going to do here is I'm going to add 6 to both sides. Okay, and then I'm going to be left with the square root of 5x plus 1 equals 6. Well, now, how do I get rid of a square root? Remember a little that if we're talking about a square root, that's the same as something to the 1/2. Well, how would I make my exponent 1, which is what we want? Well, I would have to take all of that to the second power because 1/2 times 2 gets us 1, so that's x to the first. So if I'm using a square root, then I'm going to square everything, and whatever you do to one side, you have to do to the other. So my square root and my square cancel, and what I'm left with is just what's underneath, and that's 5x plus 1, and then what's 6 squared? Well, that's 36. So be very careful when you square something. If there's a square root, they're going to cancel each other out, and you just are left with what's underneath. Okay? And now this is just a simple algebra problem. We would subtract 1 to the other side and get 5x equals 35, and then divide by 5, and you'd get x equals 7. And of course, this is going to be very important for all of these problems in this section especially, but it's good for every math problem you do. Check your answer to see if it makes sense. So we can plug our x equals 7 back into our original equation. So we'd have the square root of 5 times 7 plus 1 and then minus 6. Does that get us 0? So 7 times 5 is 35. 35 plus 1 is 36. So the square root of 36 minus 6. Does that get us 0? Well, that's 6 minus 6. So this does work. So x equals 7 is a nice answer. Okay, so this is how our basic square root functions. I would like you to pause the video and try this next one, where we have the square root of x plus 25 equals 4. So solve that and then check your answer here in a second. Alright, so if we're going to solve this next equation, there's nothing to add or subtract over to the other side. You can't touch the 25 because it's underneath the square root, so that's important that you don't do that first. So we're going to square both sides to get rid of the radical, and we're left with x plus 25, and what is 4 squared? Well, that's 16. And then of course we can subtract 25 over, so we get what? X equals negative 9. And you can always double check, plug negative 9 back into your equation, so we get the square root of negative 9 plus 25 equals 4. We want to know, does it equal 4? That's why I'm putting the question mark. Well, this negative 9 plus 25 is 16, and the square root of 16 is 4. So yes, that works, so x equals negative 9. Alright, now we're going to look at slightly more difficult problems. These are if you've got something other than a square root. You guys are used to square roots, squaring things, but now we've been talking about something to the 5th root, the 5/2 power, to the 3/2 power, 4/3, all these different fractions, and they're just the same concept as your square root, but you're just going to be dealing with different numbers. So let's look at example 2. It says negative 2/3 x to the 1/5 equals negative 2. Just like before, this would, if I wanted to write it in radical form, this would be negative 2/3 and then times the 5th root of x equals negative 2. Well, how would I get that root by itself? I have to get rid of the negative 2/3 first. So that's what I'm going to do over here. I would highly suggest being careful with your calculator. Don't rely on it, because a lot of times people are having trouble typing things incorrectly and they're getting really messed up answers. Most of the time things are going to work out pretty nicely. So what I would suggest is multiplying this by the reciprocal, okay, on both sides. You could divide by the original, but it's up to you. Okay, so what happens is that these cancel out, the 3's and the 2's, so we're left with x to the 1/5 equals, well, the negatives cancel out to make a positive, and the 2's cancel out, and what you're left with is just +3. So now, all I have to do is get rid of that 5th root, okay? Well, how do I get rid of a 5th root? It's just like the square root, okay? So I want to make the exponent a 1, so I've got this over here. So to what power do I make this so that I get x to the 1st? Well, the reciprocal of 1/5 is 5/1. So I'm going to take everything to the 5th power on both sides. So when I take 1/5 times 5, I get 1, so x to the 1st, or just x. And then, of course, you could do your 3 to the 5th power, and if you don't know that off the top of your head, you can always type that in your calculator. So 3 to the 5th gets you 243. So 243. And you always want to check your solution, so plug it back into the original, see if it works. Press the pause button and try the next one. So same concept. This one's to the 5/2. So just a quick reminder, what do we multiply 5/2 by to make it 1? Okay, so think about what you would take this to a power of, and make sure you do that on both sides, and then check your answer. Okay, so once we start solving, I went ahead and multiplied the reciprocal, so 2/5 to both sides, or I took it to a power of 2/5. Sorry, it's not multiplying by 2/5. That's a common mistake. So what should happen here is that the 2/5 cancel and the 5/2 cancel, so you're left with x plus 3 over here, and then you take the 32 to the 2/5. Well, that is the same as, and I'm going to write this over to the side, the 5th root of 32 all squared. So that's just taking the exponential form and writing it in radical form. Whatever form you're more comfortable with, stick with it. Okay, it's up to you. Don't rely on your calculator to just type all these answers in. I really want you guys to be comfortable with what this means. And if you're not sure, then please ask me before you keep moving forward. Okay, so what to the 5th power gets you 32? Well, that's easy. That should be 2. So you get 2 and then all squared, which gets you 4. So then we would go back to our problem, so we would get x plus 3 equals 4, and of course you could subtract 3 of both sides, so you get x equals 1. And you always want to take that problem or that answer, plug it back into your equation and see if it works. And if in this case you'd want your answer to end up being 32. Alright, so if you have any questions about what to take it to a power of, to cancel things out, please pause and come ask me real quick. I can go through that with you, otherwise go ahead and move on. This one's a good one to go through as well. It's a little bit more complicated. So we're dealing with the square root here, but what you notice is that the right side of the equation is not just a number, okay? And this is where it starts to get a little trickier. So just like before, my square root is on its own, okay? I don't have to move anything over because it's on its own. So how do I get rid of a square root? Well, we square both sides. Okay, so I'm going to square everything. Well, on the left side, I'm left with x minus 6, but what's different is over here, I've got something all squared. So what I would suggest is going ahead and foiling this out. Now, some of you are still having trouble with FOIL, so please be careful on this. X minus 8 squared, okay, is the same as x minus 8 times x minus 8. So please be careful not to try to shortcut this if you aren't comfortable with that, or if you keep getting the wrong answer. Write it all out if you have to. So x times x is x squared, x times negative 8 is negative 8x, negative 8 times x is negative 8x again, and then negative 8 times negative 8 is positive 64. So over here, we're going to get x squared. Combining my like terms, I get negative 16x, and then positive 64. And now I can start moving everything over and solving for x. So what I'm going to do is add 6 over to the other side, and I'm going to subtract x over. I'm doing two things at once. If you need to go back and ask me why I did that, please just feel free to stop me. But I'm going to get 0 over here because everything on the left canceled, and I'm left with x squared minus 17x and then plus 70. So I want factors of 70 that are going to get me negative 17. So that would be 1 and 70. We know we've got 7 and 10, and right there, 7 and 10 is an easy one. So we're going to go ahead and factor into our two parentheses. So we've got an x squared, so that means we have an x here and an x here. We're splitting them. And then we have our 7 and our 10 from over on the right side. And then we just need to figure out what the signs are going to be. Well, we want positive over here, but negative in the middle. So that means our signs are going to have to be either both positive or both negative. Okay. Well, if we want a negative in here, they're both going to have to be negative. So negative 7x and then negative 10x gets us negative 17. That's an easy way for you to check. And if you're still struggling with factoring, please ask for extra help. Okay. I want you guys to be comfortable with that. And then the very last step would of course be to solve. So I'm going to set each of these equal to 0. So x minus 7 equals 0, and then x minus 10 equals 0. And I would just solve for both of those. So over here I get x equals 7, and then x equals 10. So what you notice is that you have two answers now, and you want to make sure that both of those work. So please check your answers. Plug both of them in and see if either of them or both of them work. One may, maybe both don't, or maybe both do. So I'm going to do that real quick off to the side. So if I try x is 7, I'm going to kind of do this over here. I get the square root of 7 minus 6. Does that equal 7 minus 8? Well, 7 minus 6 is 1. Is the square root of 1 equal to negative 1? No. Okay, so that means x equals 7 is not a possible answer. Okay, and then I can do the same thing for my other question, or for my other answer, x equals 10. Square root of 10 minus 6, is that equal to 10 minus 8? Well, 10 minus 6 is 4, and 10 minus 8 is 2. Is the square root of 4 equal to 2? Yes, 2 is equal to 2. Okay, so this one does work. So this is an example where we have what's called an extraneous solution. Okay, extraneous solution. That's what it's called if you get an extra answer that doesn't work. Okay, so always check for those, because what will happen is when I'm grading your assignments, I'm going to be looking at to see if you wrote two answers when there should only be one. All right, so be very careful. So I would like you to go ahead and try this one right here on your own. This one's a little tougher only because you've got something that's going to have to be squared on both sides. Okay, so I'm going to start you off real quick. We're going to square both sides because it's a square root. So squaring. So over on the left we get x minus 15, but then over here you're going to have 3 minus x, the square root of x squared. Okay, what that looks like is 3 minus square root of x times the 3 minus the square root of x. So you need to FOIL that out and then continue solving. So try that one on your own and see if you get the same answers as me. Alright, so let's check our answer. When I FOILed this, I got 3 times 3 is 9. 3 times negative root x is negative 3 root x. And then right there we get negative 3 root x again. And then negative root x times negative root x. Square roots cancel each other out, so we get positive x. So right here I get x, and then minus 6 root x, and then plus 9. And now I can start moving things to one side. So I'm going to subtract the x over here and add the 15 to the other side. Okay, just moving everything over to 1. So these cancel. So I'm left with 0 equals x minus x cancels it out. So negative 6 times the square root of x. And then 9 plus 15. So that's 24. Okay, and then we can now start solving. So I would subtract 24 over. So I get negative 24 equals negative 6 square root of x. Divide by negative 6 on both sides. So we get that the square root of x is equal to, well, what's negative 24 divided by negative 6? That's positive 4. And last but not least, get rid of a square root. We square both sides. So I get x is equal to 16. And of course, always, always, always check your answer. I can't say it enough. So you would want to plug that in and see if that works. Okay. All right, now this is another example where you've got that weird cube root or a different root on the top. So if you want to see this extra practice, that's always fine. It's an example for you. If you're comfortable and you know you're good, you can always move forward. So I'm going to do this one real quick. Well, I want to get rid of the 4/3, so I'm going to take it to the 3/4 power. So to the 3/4. My exponents on the left cancel, and I'm left with x minus 5. And then, of course, I can use my calculator. Remember, this is the 4th root of 81, all to the 3rd power. So what to the 4th root gets us 81? So 81 to the 4th, that gets us 3. And then 3 cubed gets us 27. So we get x minus 5 equals 27, and then add 5 over. So x is going to equal 32. Okay? Always check your answers, see if it works. And then you're good to go. So that's a pretty short one, but I really want to see all those steps, show all your work. I will be giving credit for that, so don't be lazy. It doesn't take long to do that. This is one that's really nice. If you've got square roots on both sides, you are going to do the same thing. Obviously, there's nothing you can move over to one side or the other to make it easier. So what I would suggest doing is just getting rid of those radicals as quickly as possible. So how do we get rid of a square root? We square both sides, okay? Well, what happens in this case, since you're taking it to a power on both, and both of them are square roots, they're going to cancel on both sides. So what I'm left with on the left is just 2x plus 5, because my square and my square root cancel. And then over here, the same thing happens. I have a square and a square root, and I'm left with x plus 7. And now this is a simple algebra problem. Start solving for x. So I'm going to subtract x over. So I get x plus 5 equals 7, and then I can subtract 5 over to the other side, and I get x equals 2. Okay, and always, like I said, check your work. So I'm going to do my little check right here. Square root of 2 times 2 plus 5. Does that equal the square root of 2 plus 7? Well, it's 2 times 2. That's 4. Plus 5 is 9. So does the square root of 9 equal the square root of 9? Yes, it does. So there's our answer. All right, now this has all been algebraic ways of solving, okay, but you can also solve by graphing, and some of you like to look at visuals. That's perfectly okay if this is what you're comfortable with. Now, I really want you to be comfortable with the algebraic way, because you may not always have access to your computer, but on homework and things like that, use it if you're capable. So let's look at the first example right here. This says we have the square root of x equals x minus 2. This is one where you'd end up having to FOIL and then factor, and some of you are not comfortable with that. So go to Desmos, or if you have a graphing calculator, use that, and you're going to type it in. So I've got Desmos pulled up right here. So what I'm going to do is I'm going to take what my left side of my equation is, and I'm going to type that in. So y equals the square root of x, okay? And then, so notice that plotted on my graph, oops. Sorry guys, my computer. There we go. So y equals the square root of x. Sorry about that. Click the wrong button. That graphed right here in this red line. And then I can also type in x minus 2. So y equals x minus 2. So I've got two different graphs, and I want to know when they're equal. So in other words, where do they cross? This is a really easy way to find solutions. So right here we've got where they cross is at 4, 2. Simple solution, and of course you could always plug that back in and see. So because it said that it crossed at x equals 4, okay, so my equation is x equals 4, plug it into the original and check and make sure that it still works. So if I have the square root of 4, does that equal 4 minus 2? Well, that is 2 equals 2, which it does, so x equals 4 is your answer. All right? I want to also show you one more where it may not cross. So let's look at what we have here. We have x minus 1 to the 3 halves, and then equals negative 3. So I'm going to have x minus 1 to the 3 halves. And if you're not sure how to type that in, let me know. So that's my equation here in red. And then it said that x equals negative 3. Y equals negative 3. So there's my equation. So what you should notice is that I've got a red line and a blue line, and they never cross. So this is a problem where if you were solving, you would get no solution, or maybe an extraneous solution when you solve. So in this case, you would just write no solution. Okay, so they never cross. and so there's no answer. Now, if you try to solve that algebraically, you may get a number answer out, and that's the case where you might have an extraneous solution. So just be really careful that you're always checking your answers. I can't emphasize that enough. I don't want you guys losing points over silly little things for not checking your work or plugging something back in. It takes 2 seconds, and that should help you guys out a lot with your solutions. If you have any questions over this, or you want to see some more graphs or see some more algebraic problems or factoring, just come see me. I'll give you some extra examples. Otherwise, you guys can start working on that assignment. Thanks for listening.